The forest should produce volume and money to the society.
We can lost hundreds of crowns on every tree if you don't do right.
So each year I walk around here with a ladder and a small saw, and I climb up and clear the stem.
When you see this kind of log, you check the annual rings first. All right, you got 12 or you got not 12.
Sharpening, it's very important to have sharp tools when you would cut in wood.
We are focusing in the wood drying and how to systematically improve the drying process for sawmills.
At the moment we're producing about 250,000 cubic meters each year.
With that, sell the wood in any country in Europe because we have the same classes.
Of today, it's the material have the best climate impact in when you want to build a house or construction, whatever.
If there happens something in the forest, it's very important to have biological diversity.
The TreProX participants are now here in Sweden, and we are looking forward to the agenda that our colleagues at Linné University have prepared for us. It's actually quite tight, so we think it will be very intensive, but we hope to learn a lot from this. We will have visits and lectures, and it actually is very exciting for us when we come from Iceland to these wooded areas here in Sweden, that we feel as if we are just going to learn from the best.
Compare Iceland and Sweden is very interesting. You are, you can say, 100 years after us. In the south of Sweden we had an open or half open to completely open landscape without trees, with heather moors and so on. And in the end of 1900 Iceland started to regenerate, sort of reforestation. We started our journey with forestry 1820 or something like that. And then 100 years after it really took advantage and speed. So today we have in the south part of Sweden 5 times more of forest compared to what we had 100 years earlier. The reason why we got all this forest was of course the industry. The industry wanted timber and the society wanted money to build up a welfare country. The focus was to produce timber and pulpwood. That's it. Spruce and pine. And then we got the knowledge about environmental questions in the end of 1900, and we started to add this to the forestry. And today, since 1993, it's a mix of production or a balance with environmental questions.
If there happens something in the forest, it's very important to have biological diversity. It's a much higher diversity in nature forest than especially in clear-cutting forest. It's a real great. You can't compare them, in fact. A more natural forest can retain nutrients, carbon and water more than in monoculture. I think that is also important if you want a more sustainable forestry, generation after generation.
If you see a stand who is 50 years old, you must add 40 years, because the people who reforested this area was born 90 years earlier, and they were born in a society. You must understand that we have a production of forests with 50 to 130 years or something like that in Sweden. It takes time. We can call it mistakes, we can't undo them. The forest is what it is. We are producing since 1995. It's completely different compared to the periods before.
It is about how to cut the tree on the right places to get optimal logs for the next use of it, and also it can be useful for many sorts of things. Remember, you have steps, 5 steps from quality You have price steps from the length. You will get more paid for long log and will less paid for short. And you have also steps from the diameter. There's a diameter classes, 2 centimeter, 2 centimeters interval. Those are also price steps on those. So you have to work with 3 different price steps in those kinds. And the price of the pulpwood is 400 kronor per foot.
7,5.
So these open lands, we left the meadows and where we were grassing in the forest. That was a result of hundreds or thousands of years of farming, you can say. These areas, the meadows and so on, it has enormous biodiversity, and we are losing these areas, the whole Europe. And if you just leave them and doesn't do anything, it will be forest in a quite short time. 20, 30, 50 years, it's a forest. Then we lose the habitats for many flowers and insects and butterflies. So that is a question about what kind of food do we want to eat. We must eat meat and products from meadows. And the only thing we can manage this is with cows and sheep and perhaps some goats. And this is very expensive, very expensive. And today we don't want to pay for it.
Yes, you can. If you will describe the monoculture, then you have usually one tree, of course, and the same age, one level in the forest. To have several levels in the forest is, for example, important for birds to hide, to nest, and so on. So there's a lot of things for the. And then several levels. If you don't clear cut, the low level can be the new forest if you cut the some of the old trees. And then you have a regenerated forestry. You can have a forestry that mimic the natural forest and the natural forest disturbances. If it can use that, then you will have the diversity and the 3 R's: resistance, resilience and redundance.
Bent Törsgate, vad heter det på it's a fungi who goes attack the pine, mostly just below the crown or halfway up in the crown. So I think I'm not allowed to make a clear cut here because of environmental laws. And it doesn't matter because I don't want to do it anymore. That's beautiful. You can also see how the shade is an advantage for spruce. This is totally self-regenerated. And I would say when the forest are allowed to choose itself, it will be more spruce when you have shade above, and it will be more pine when you have more sunshine. You see the difference how the spruces come in the dense stand of bigger trees. You have no pine. It's a win-win. You will get smaller branches and less juvenile wood. Yeah. It is a little bit curved. At the moment I left it for concurrent, also in competition to the other one. It will make a natural pruning and it will have a break from that one to the right. The top, but maybe it will straight out. So if I come here in 5 years or something, and that seems to be straight, I will take the other fossil on the left. It's quite low dense because it was a natural opening and some rocks, stones. So, but if we imagine I have made a hectare here with the same method, I have been 5 to 7 years. I make the next filling and then I take out some wood, pulpwood.
In older time, the creeks and the small streams, it was open. It was meadows close to these areas, of course, because there you find best grassing areas. And today we have changed it so much, so sometimes it's spruce close to this water system. And then you will have humusämnen, humus. The water will be more brownish and not so clear anymore. And the reason is more forest, more spruce perhaps, but you should also have the same problem, I'm sure, with beech and oak close to the streams. The water is very important, and to have another type of forestry close to the water. Better to have black alder or birch or ash or whatever close to the streams, and that will produce much more insects in the water, in the little streams, and you will have more fish and so on.
The forest is very important for people's health, for recovery. A lot of people now goes in the forest when they don't go to Thailand. They want to go in the forest instead. It's rather often crowded in the nature reserves in Sweden. Some of them especially outside Stockholm, for example. So that's an important thing, and it's important to people can be near the nature to pick berries and mushrooms and so on. We do a lot in Sweden. And I think it's important to have big animals in the forest to create a lot of things. They create a lot of things, as we had in Sweden with forest grazing earlier, and even in agriculture. So there's a very strict limit today. It's ideal if you can mix them a bit. So benefit there and benefit there.
Over time, under this last 100 years, we have the double volume of forest, and that have of course fixed the double amount of carbon dioxide. But it is also interesting to see how much of this carbon is stuck in the soil. And then many people are talking about the upper layer, the biosphere, but I am talking about the soil, the carbon in the soil. And if you take a long period, 10,000 years since the ice sheet was gone, we have stored 7 kilos carbon per hectare over time in Sweden. But if we have active forestry, we can go up to 150 kilos of carbon in the soil. And if we have a method with close to nature or clear cutting, it doesn't matter, because that amount is fixed in the soil. I mean the real soil. But of course, if you clear cut an area, the upper layer, the roots, fungus system and whatever, that is going up in carbon dioxide again. And today 70% of the land of Sweden is forest land. When we cut some hectares and use this standing volume for building a house, we store carbon dioxide in the house, but nearly 2/3 of the volume is used for other purpose. Lots of it is bioenergy, for example. Bioenergy is the largest producer of energy in Sweden today. And then we make lots of paper, and today also textiles and so on. So when you build a house of wood, you have a flood of other products which is used instead of fossil energy, plastic. We use paper instead of plastic for heating the houses, produce electricity. For example, this city here, Växjö, 80% of the heating in this city is heated by bioenergy, and really 50% of the electricity is coming from bioenergy. So if we don't have this bioenergy, what is the alternative? What is the alternative to build a house of wood and these streams? That is concrete, steel, plastic. And then you don't have this possibility with bioeconomy and sustainable society.
Laminated wood have been for many years ago, from the Pharaohs' time, but it was like 1920 when we started to have synthetic adhesive. We can make a glue lam in a way that could bear strength, load from a load capacity. Before that we have to secure the glue lam, so then we use fittings, nails and so on. And the most famous buildings, I think, in Sweden is the Stockholm Central Station, where you can see an excellent example of glue lam strengthened by nails and metal fittings, bonded by an old glue who was not so strong, called casein lim, made of milk. The development of lamination of wood was increased, enhanced in the Second World War, when there was a scarcity of steel and aluminium. So I've been working a lot about shape stability in such laminations, and also the strength of the bond line itself. I think it's possible to use that kind of knowledge in also components for house buildings. many skilled person working in this area. Best example is sealed cross-laminated timber invented by Johanson in Graz, Austria, and we have get inspired by him in Sweden. So we have now 5 factories producing CLT panels. So CLT panels for high buildings, and also columns and beam systems are also popular with high wood buildings. So I think we are beginning of this area to use, let's say, knowledge from aircrafts to furniture, now to house buildings.
This big load frame, this is one of the biggest in Northern Europe. There are one in Borås at Rice and one in Copenhagen, and this one. And it's all brand new, this load frame. This has been discussed for nearly 20 years, this load frame, and it's prepared, the floor was prepared for this machine. And I designed this machine now for a year and put it together like a month ago, something like that. So this is brand new, and this is the first test we're going to do. And this test that I've set up right now is just for test. We're going to do tests with much bigger CLT panels, cross-laminated timber panels.
What I think is very nice place to go and visit in Stockholm is Cederhusen. It's an area in Hagastaden in Stockholm where they have built wood houses by the company Folkhem. And that's also very interesting because they have built over a big road called E4. So they have taken away that lousy area with the road and built a town over it. And that wood houses have a lower weight than concrete houses. They could have more floors because they have built the houses by CLT panels compared to what they have been able to build with concrete panels. So the houses at least 11 floors height, and if they have used concrete it have been much less, at least half of it, I think. But at the same time there's lots of people who want to use wood because today it's the material have the best climate impact in when you want to build a house or construction, whatever. So we have to take care of the wood material in a better way than what we are doing today, so we can reuse it and use it smarter, more resource efficient than we are using today.
This panel is made out of studs and so on. We were taking the quality of this material much higher, up to C40 quality. And that will make much better mechanical behaviors, take much more force and so on, and you can make it smaller. Today you just make it of C24, and yeah, we want to go up in quality and use more of the best quality wood used normally. And that's because we want to see how much smaller we can do the panels with the same behavior and so on. And that's for, of course, taking care of the wood and the forest and all the material better. We use a 3D camera, digital correlation system, and this measures in 3D, and we put on a speckle pattern on the object, and then we can see exactly how it moves. Everything moves. We can down to hundreds of millimeters, we can measure everything. So that's quite fancy system, this RME system. After this we're going to do tests with connections with CLT also, with 2 CLT panels with the connections, and try to bend it and see what force we can handle with the connections. That's also one project, and after that we're going to do a really big project with the house volumes here and test for wind load, really big. So you could take the whole space here, and we're going to push up with up to 250 kilonewtons, and we're going to have 14,000 kilos of sand up to simulate 6-story building. So the 5 stores we simulate with this sand up, and we're going to test what's happening when we push it. So, and that we're going to have double of this camera system and a lot of sensors, and everything is going to big acquisition of data so we can use for the future for research and so on.
A piece of wood can be used in many ways in a construction, and there will be different forces acting on it. So you have bending strength, it will bend down, and then you have compression when you take the force like this, and compression perpendicular to the fibers, pressure like this. Every country had their own grading rules, and now with the CE marking and 338, there are tabulated values. So each sorting grade corresponds to a certain C class or D class if it's broadleaf wood in the table. So you can sell the wood in any country in Europe because we have the same classes.
We can paint the windows in linseed oil, but then we can only paint once at a time. Och under förmiddagen så var gruppen i skogen utanför Lenhovda för att lära sig att kapa träd. Dan Johanson, du är skogsägare i Lessebo och kurshandledare. Hur går det för dem?
Jag tycker det går jättebra. Det går mycket över förväntan. Och jag hade förmånen att få vara på Island en vecka i höstas och bekanta mig lite. Och jag trodde att de allmänna kunskaperna skulle vara mycket lägre. Så jag är riktigt imponerad av dem.
There's a lot of Danish svenskafs. So I think though we've got the general idea, and what we want to find is like how we can split the tree to get as many logs as possible. The main part is just when like one log class stops, we have to do our little calculation, and then for the next part we'll measure the size and volume for another log grade. And then once we run out of log grades, it's mostly pulp grade at the very end. Yeah. So I think it's going well.
Det är ju en gård där uppe och till den gården hör det ju åkrar. Så det har ju vuxit igen. Ja. Så det här var ju givetvis en kantzon också då.
Okej. Lite extra ut.
Ja, så den skog som man ser bortanför här, det är ju första generation. Ja. Hemsk skog har det varit där.
5% of trees in a stand will never go up to the straight or go over to the right hand. 5% will remain left. Spiral grain less than 4 degrees. If you check the angle, less than 4 degrees will remain. Also boards, wood, planks and boards with a spiral grain from logs with a spiral grain less than 4 degrees will remain straight. I don't agree totally with him because it is also like Björn said yesterday, it depends on how low you will dry it. If you dry it to 18-20% with normal drying at the sawmill, maybe it's straight, but what happens if you go down to 6%, 8%, then it could occur some twist. But this one, I will say, it in normal case will remain straight.
Trees are not growing with the idea of becoming planks. The trees don't consider our sawmills. They grow to become as strong as possible to live as long as possible. So actually what the tree does is that it creates sort of plywood. They start with spiral grain to the left and then straight and goes over to spiral grain to the right. And that creates a cross pattern of the fibers in the trunk from the center of the trunk to the surface of the trunk and make it incredibly much stronger against winds and bending and so on and splitting and everything. So it's really a reason, it's caused by the need of the tree to be standing a long time. If you visit north of where I live in Dalarna, the oldest living tree on earth, or one of the oldest, there are so many oldest living trees on earth, is a spruce that is between 8,000 and 9,000 years old, that is still growing. And in that area, when you look at the old trees and the dead trees, and you look at the spiral grain, it can be 45 degrees to the right. And that's extremely, extremely old trees, growing very high up in the mountain ranges and so on.
Real men smell diesel and real men like that.
We'll see. Magic.
I can't. I was just 13 years when I worked on this hill and started to film the oaks and some other species. And at that moment, I don't know how I thought, and I don't remember. But it has been some, I would say, since the last 25-30 years, I have had a clear strategy to get straight stems and keep water sprouts. Thank you. So each year I walk around here with a ladder and a small saw, and I climb up and clear the stem and walk on. So I have about 200-250 oaks like that. If you talk about other people who are better than me and have worked much longer with active oak management, the target diameter in chest height, as we say in Sweden, burst height, is about 80 centimeters when they are mature to cut down. So this one is it is on a good way to 80 centimeters, but yes, we have no tradition of active oak management here. So if we have had oaks with bigger diameters too, but hopefully I live so long so I can cut that one and maybe some more. That's red ring around the tree. You can see it through the branches, through the bushes, some small red ring down there. I would have said you could take the big pine and help that birch. It's a very good birch by Bjarke, just in front of Bjarke. If it isn't a curve from the other, so do you see a curve on that place?
Yeah, there's a branch that's kind of coming out from. Okay,
maybe.
What can you do with purpose?
Just for biodiversity, and maybe we don't want it because the nutrition is not so much because that's so much shade. It needs sunshine to taste good.
Here we are at Elmia University. The specialists from the university are teaching us how to grade timber. And we've got some pines and spruce logs, and as you can see, people are very interested in seeing how things are done.
It's complicated. It's a lot of numbers and words in our manual, but however, you can simple it up very much. When you see this kind of log, you check the annual rings first. All right, you got 12 or you got not 12. That's a crucial. This one, for example, it can't be a class 1. For class 1, only the first log in a pine tree. You have to simple it up. Then you check the twigs. All right, what you're searching for? You're searching for this one who is connected to the wood. Okay, that's no problem. The dangerous twig have you got here? All right, it's over 60 or not? It's not over 60. So you can simple it up very much. So there's no rocket science. When you see this type of log, you got your eyes directly on this one. Is it more than 5% or not? Oh, this one, yeah, it's from the machine in the forest. What have you got more here? Oh.
22.
It's still not. If you got 20 annual rings there, you can read the text and you say in class 1, 2, 3, this is not allowed. Yes, you have only the 4th class left. And then you have to decide, is it more than 5% or not? In this case, it's under 5% and it's class 4. So you can simple up very much. How about this one? There's no problem, it's still a class 4. Here you must concentrate, perhaps stop and go and count. Here you can see it's still you get counting the annual rings. All right, 21. All right. How about the twigs? There is no twigs. That has a class 1. But you know, you have to lay focus on this one, the best of the logs. This one, for example. All right. Oh, perhaps not class 1 because it's not a first log. Then you check out this one. Oh, it's over 60 millimeters. And it's qualified for the class 4. So you have to simple it up. You don't start in the tab and read it on. Simple it up, check what kind of log it is. For that one, for example, oh shit, you think? It have grown very heavy here, very fast. But you see in the center, it's very small annual rings here. But in this case, it's the first log of a spruce. You have to check in the other side. It's Röta here, and that's qualified to the second class. So you have to simple it up. I say it again. It's not so complicated. And about the twigs, 20 millimeters, 60 millimeters, and 120 millimeters. So there's not so many of them, different styles of twigs. So we'll simple it up. That's the key. Yes. Uh-oh.
And today, normally when you are sawing the logs, you want the best log and high quality. But today, Andreas and we have chosen the worst log, just to demonstrate and see how looks the problem inside. When I started my business 2006, it wasn't so many machines on the market. Many new models have come, new machines with tractor, electric, diesel motors, and so on. I often get the question, what machine should I choose? Who is the best? Small, big, what should I do? And you have to choose a machine who is the best for your area and for your business. I like this blade, is the Wood Mizer.
Yeah, Wood Mizer in Canada.
Yeah. Normally, the tooth is 11 degrees, but in hardwood, very hardwood, we have only 9. I could have a bigger sawmill, but a bigger sawmill is more expensive. And a bigger sawmill also makes more logs per hour. But when I'm with a customer, normally I run the sawmill and the customer, and sometimes the customer and a friend take care of the product that comes out. And with a bigger sawmill, they have to be 3-4 persons. If they are only the customer or one person more, it doesn't help if I fix 20 logs per hour, because they must take it away also. This is my personal opinion. A chainsaw is sensitive, but this is absolutely more sensitive. The result is here. Mostly of the result is here, not here. If this is green or black or red or yellow.
Yeah, okay, so this is what we see mainly. One piece of wood, yeah, whatever. The contrast is very good. Every pixel in this camera is very sensitive to a change in temperature. So what we do here with this technique here is that we fix the temperature to two different known temperatures. One temperature is the wet bulb temperature. That is the normal way to measure the humidity. And we know what that is in the dry because we measure it with a temperature, ordinary temperature sensor. And then we have the dry bulb temperature. So we have these two fixed points. And with that, these two measures in the camera picture, we could quite precise measure the board temperature. So the board temperature will be somewhere in between this wet bulb temperature and the dry bulb temperature. The production needs to be high, so you don't have the time sometimes you need to go down as quick as possible with the right quality on the board. So this could be a technique where you actually can see something more.
I'm the owner of this farm, and we have quite a big 900 hectares totally, about 810 productive. We take out between 2,500 and 3,000 cubic meters every year out of the forest. It's grown in about 4,300 cubic meters every year. The mixture is 70% pine, and 25 spruce, and the rest is leaf, most beige. Me and my wife and my son is still live here, so we work here with that all alone. And we do every forest work by ourselves. Everything in the forest we do it by ourselves from the start to the end.
Das ist bitter. Noch für lätt.
18, 20, 22, 24 and so on. So, and this is matrix. That means if you can cut a long log, you will get more paid, you will get 15% more, and if you cut it short, you will get 37 in this case, you will get less, 15% off the price.
Wow.
And you're allowed to make 31s and use the same length correction as for 37. That means 85%.
In the sawmill we produce, we can say we saw about 150 cubic meters every year. A lot of that is for building house and such a things. We are the 7th generation now. It started with 324 hectares, 1956, and from that
have you found out how
gone up.
prices work? Here we can see something has happened. There's a small curve, and we have reaction wood here. We have low density. We have probably more juvenile wood, so it's a discussion. Is it something that we should think about for the sawmill? What has happened here?
I don't know.
This is a big branch. You see me? Here's some sign of an old branch, I should say. But you don't see it now, but it seems that something has happened there.
Mostly we do this. We see. We don't set plants. We see. We want to get up a lot of plants, and you can get up to 10,000 trees on a hectare. It gets you a lot of job later, but we have also animals in the forest who like the trees, especially the pine. When they are small, we have a lot of raw deer, and when they get higher up, the moose take a lot. Hopefully I can even get a good quality when they grown up tight. Grown up here with a forest around me, and the forest is central in our family. And when I went to school to learn foresting, it was chainsaws. But we know the machine was going on in the 80s, and they started already in the 60s, but they were very big and not the best quality. So when I finished that, nearly direct, I buy me a forest machine who was older than me. Of course, I was very interested in machines. In 20 years, I worked like an entrepreneur with forest machines. I have 3 harvesters, 2 forwarder, and people who help me, of course, with that. For the thinning, when trees are small, we have a smaller machine. It's Blow, and a local product from Röntgen. It's only 1.8 meters wide. The last thing we do, I take that machine.
When a tree has stands nearly 100, these are stand in 92 years. It's very important to cut them in the right pieces to get most money. When I use the machine, I have help with the diameter and length, and the computer have even correction for the best length in that diameter. But it's always me who decide to cut. The computer don't see any damage or something, or bows. So I chose. You can lose hundreds of crowns on every tree if you don't do right. They used to say harvest a pilot is like a pilot in fight up in the air. It's a lot of decisions in a short time. And after a day, when you have produced 1,000 trees on a shift, you are tired in your brain. I promise you that.
Who I felt before.
Sharpening, it's very important to have sharp tools when you would cut in in wood pieces, because it's not help if you have the biggest and most exclusive saw if you don't have a sharp saw blade in it, and you must know little about what type of material you have in the saw blade and what teeth you have, and if it would be hard metal or carbon steel or high speed steel, and this type of information of that are tools that you set in a saw. It can be a chainsaw, it can be a wood chipper, and regular bandsaw or saw blades. So this type of cutting information are very important in the whole sector of this, because all tools must be sharp. A very cheap tool can be good if it's sharp, I would say. So you must know how you're sharpening it, but a good quality tool and a sharp, when you combine it, it's been very good results.
Welcome to GGA, a sawmill in the south of Sweden, Småland. It's a family-owned sawmill and has been so since 1928. It was my grandfather's father who started it, and the area is about 34 acres. In the south of the site there is a small village for about 500 people living. In the other directions, to north, west and east, it's only forest, so we have not so much problem with the noise, which can be a huge problem for sawmills. We are about 100 employees. We're working daytime and in the evening. At nighttime we have some maintenance going on. At the moment we're producing about 250,000 cubic meters each year. And most of it is spruce. At the moment we're producing pine. And the main part of it is planed, about 70%. The production consists of a sawmill, sorting station and a planer. The sawmill has two lines, saw lines. One line is for the normal timber, which takes timber from 22 centimeters in the top up to like 50 centimeters, and the other line takes the smaller logs that is like 22 and down to 10 centimeters in the top. After it's been sawn, the wood goes through our kilns, and after that it goes through the sorting station. In the sorting station we sort each piece into the correct quality and the correct length. So from the sorting station there only comes out a package which consists of the same length and quality.
It's like 4 weeks you are not allowed to.
We have 4 weeks holidays here, yes, and repair everything.
And to
Midsummer.
Yeah. And to ensure to have production when we get back from holidays, we have this timber stock, which is water spray, so we can start as soon as possible after the holidays.
And that wood behaves quite differently to any other wood when you dry it, in many aspects. So it's the first weeks after starting sawing are quite different to normal. I don't like it. It's difficult to do a good moisture. Some pieces is 70-80 and some pieces is 25-30, because the cells in the woods sluts, so water can't go out.
Because of this process?
The pores are closing.
Because of this wetting?
No, because they are starting to dry, and the wetting is not perfect. So some of the wood is starting to dry. Some of it is getting starts of bacteria.
One of the byproducts is the chips, which came out from the sawmill line. All of that chips goes through the paper industry. About 13 to 20 trucks comes here and pick up the ships and delivers to the paper plants each day. We have 10 forklifts working here, both shifts, morning and evening. Each day there is more than 50 trucks delivering logs to this site, and on the opposite side there is about 30 to 40 trucks delivering goods to the shops. We're exporting about 60% of our production. The main part is to Holland, Belgium, England, some in Denmark, the northern parts of Africa, and some on China. And the rest is on the Swedish market, of course, and it's mainly to the grocery stores. The boiler is used for bringing up the heat to our kilns. It's a boiler which has power of 9.5 megawatts. We use all of that by ourselves now. Previously, we delivered heat through the village here. We don't do it anymore because we need all that energy ourselves. The kilns dry down the wood down to 18 to 20% of humidity. When it comes in to the kiln, it is approximately 30 to 40% of humidity in it.
First Forest Act 1903, a little bit over 100 years ago, and the legislation was at that time reforestation, and then we had a legislation or an act where we're not allowed to cut a forest who had a certain age, and then we added the economical point of view in the 40s. The forest should produce volume and money to the society. And the whole time the forest owners, the private forest owners and the companies, they are discussing these questions with the government and the society, a dialogue or discussion. The forest owners, they nearly always follow the law and will do the best for the society. But today we have a period when you are looking very much to your own private economy, and you can say that if you have continuous forestry, you just cut down some trees, the big trees, reforestation, the regeneration should fix it itself, and then you are back again as we was before we had the Forest Act. Most important thing now is to the same level of standing volume over a region. So if you change laws and systems and we are losing or diminishing the standing volume, then we have a leakage of carbon dioxide in enormous amounts. So 1% of the standing volume in Sweden, 3.6 million multiplied with 1.4. Then we have a leakage of carbon dioxide, roughly 50 million tons of carbon dioxide. The laws and the discussions and the dialogue with the forest owners is very important. Very, very important. Oh.
Now the TreProX participants have been here in Sweden for a week. We've had interesting lectures, we've visited farmers with forests, we've seen sawmills of very various scales, and I think we need at least a few days, if not weeks, to digest it all. We've learned so much. And now we are finishing up with our visit here to Elmia, the biggest forest fair, so we are trying to gain even more knowledge before we go home.
Every tree